Welcome to this SkillPad video resource, where we make learning simple. In this video, we're going to dive into the fascinating world of matter. What is matter, you ask? It's everything around you. Matter is anything that takes up space and has mass. Your phone? Matter. Your pet hamster? Matter. Even the air we breathe, though we can't see it, is matter. That's right. Air has mass and occupies space. Don't believe me? Try blowing up a balloon. See how it expands? That's the air taking up more space. So the next time you're wondering what matter is, just remember, if you can weigh it or it takes up space, it's matter. Matter is indeed all around us. Now that we know what matter is, let's talk about the different forms it can take: solid, liquid, and gas. We call these the states of matter. Solids, like rocks and ice, have a fixed shape and volume. Their particles are tightly packed together, giving them a rigid structure. Liquids, such as water and juice, have a fixed volume but take the shape of their container. Their particles are close together but can move around more freely than in solids. Gases, like air and steam, have no fixed shape or volume. They expand to fill any container they are in. Their particles are far apart and move around rapidly. Think about it. You can easily change the shape of a liquid by pouring it into a different container, but you can't do that with a solid without breaking it. And gases? They're everywhere, filling up every nook and cranny. Now, you better hold on to your hats, because we're about to get a little more technical. The key to understanding the states of matter is the kinetic theory. This theory states that all matter is made up of tiny particles that are in constant motion. The faster these particles move, the more energy they have. And guess what? Temperature is a measure of this energy. In solids, the particles are tightly packed and vibrate in place. They don't have enough energy to move around freely. In liquids, the particles have more energy and can move around each other. They're still close together, but they're not stuck in fixed positions. In gases, the particles have the most energy and are far apart. They zip around at high speeds, colliding with each other and the walls of their container. So, the next time you see ice melt into water or water boil into steam, remember, it's all about the motion of those tiny particles. Now, let us examine how particles behave in different states. Let's imagine we have a super powerful microscope that allows us to see the particles in matter. What would we see? In a solid, the particles are arranged in a regular repeating pattern. They're held together by strong forces of attraction, which is why solids have a fixed shape and volume. In a liquid, the particles are still close together, but they're not arranged in a fixed pattern. They can move around each other, which is why liquids can flow and take the shape of their container. In a gas, the particles are much farther apart and move around randomly. There are very weak forces of attraction between them, which is why gases have no fixed shape or volume. It's like a dance floor. In a solid, everyone is glued to their spot, just swaying to the music. In a liquid, people can move around but are still pretty crowded. In a gas, it's a free-for-all. Now for the really cool part. How does matter change from one state to another? The answer is heat. When you heat a substance, you're giving its particles more energy to move. If you add enough heat, the particles will overcome the forces holding them together and change states. Heating a solid can turn it into a liquid through a process called melting. Think about ice melting into water on a hot day. Heating a liquid can turn it into a gas through a process called vaporization or boiling. That's what happens when you boil water on the stove. Cooling a gas can turn it into a liquid through a process called condensation. Think about the water droplets that form on a cold glass of lemonade on a humid day. Cooling a liquid can turn it into a solid through a process called freezing. That's how ice cream stays solid in the freezer. So remember, adding heat gives particles more energy to break free, while removing heat slows them down and allows them to get closer together. Lastly, let us look at the effect of evaporation on body temperature regulation. Have you ever wondered how sweating helps us cool down on a hot day? It's all thanks to evaporation. Evaporation is the process of a liquid changing into a gas at the surface of the liquid. When our sweat evaporates, it takes away some of our body heat, leaving us feeling cooler. Here's how it works. When we get hot, our bodies sweat to release excess heat. As the sweat evaporates from our skin, It takes some of that heat energy with it, which cools us down. It's like a natural air conditioner. Pretty cool, huh? So, the next time you work up a sweat, remember that it's your body's way of staying cool and comfortable. Thank you for using this SkillPad video resource. We hope it was insightful. Come along as we wade into the world of science for your learning pleasure. We hope to see you again soon.